Standard form, online assignment number 1, graph the linear equation y equals -3. Y equals -3 right there. And here, 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 it's horizontal, all on that because of Vux and Hoy. Vux is vertical line, undefined slope, and it's x equals Hoy is horizontal line, 0 slope, and y equals, by the way, these little squigglies have nothing to do with it other than that's how I was using them to talk about it. Graph the linear equation x equals -1.5. Where does x equal -1.5? How about here? And here, all up and down that line. That's number 2. Find the x and y intercepts of the graph of this linear equation. Boom. This dude's in standard form. Ax by equals c. Notice that that is a negative, and so from what I know, it should be positive, but we don't really care about that right now. The x-intercept is when y equals 0. So y equals 0, you get this, and x would equal 3. So the x-intercept is 3, 0. And the y-intercept happens when x equals 0. So we got to erase this little chunk. And we got to get rid of that because x is now 0. You get 9y equals -18. So y equals -2. The y-intercept is -2. 0, -2. So maybe they're not exactly giving them to us in standard form, but they are asking us to find the x and y intercepts. So really, what I'm going to do is plug in for the x-intercept. Y is 0, so okay, y is 0. And what we're left with is 3/4 plus x equals 0. So, I mean, we could pretty easily do that in our head. And x is -3/4. Also, I looked up the answer just to see if they wanted coordinates or if they want just a number. Apparently just a number checks out just fine. Let's find the y-intercept. So the y-intercept happens when x is 0, so see you later. And this might seem horrific that we have 3/4 equals 1/2 y, but I'm just going to multiply everything by 2, and I ended up getting 3/2. 3/2. And it's positive, right? Yep, because that's positive. There we go. Use the intercepts to graph the linear equation. Well, here's where they're asking us to do standard form. Definitely in standard form. Standard form, what we do is you can rearrange it if you'd like, but they specifically want the intercepts. So I'm curious, hang on. I just looked up the answer and they specifically, like the dots on their graph are the intercepts. So it looks like they want you to do it kind of the x-intercept way is getting rid of the y. So the x-intercept is 3. So here we go, 3. The y-intercept, well, we got to get rid of that first. The y-intercept happens when x is 0. 6y is 12, so y equals 2. Right there, and something like that. Identify the corresponding points to the intercepts. Well, we did that. So the x-intercept is 3, 0. The y-intercept is 0, 2. Cool. Well, maybe I was lying. Maybe they're lying because there's a negative right there. And generally speaking, it's supposed to be positive, but whatever. Here we go. They want us to use the intercepts again. So the x-intercept is like this. -2x equals 18. It's at x equals -9, right about there. The y-intercept, gotta erase that real quick. The y-intercept happens here at 6y equals 18, or y equals 3, right there. Careful of the scale of the graph. They count by 2s, right? Here's our graph. Identify those corresponding points. The x-intercept, -9, 0. The y-intercept, 0, 3. Use the intercepts. The x-intercept is, oh, okay, so we finally have a not really pretty looking one. That's okay. And I say that because this is going to be 10.5. So x is 10.5. Again, kind of pay attention to the scale of the graph. They have halves in here, right? And then the y-intercept, well, remember we got to erase that. The y-intercept happens here. 7y equals negative 21. Y equals negative 3. Right there. Here's our graph, something like that. And all right, the x-intercept was 9.50. The y-intercept was 0, negative 3. Use the intercepts. The x-intercept, well, again, they've kind of gone funky with us. The x-intercept is when y is 0. So we just have this, right? Subtract the 5, divide by 3, negative 5/3. Cool. Oh, how funny. The graph has it like that. So really, if you want the mixed number, this is negative 1 2/3. How did I do that? Because 3 goes into 5 one whole time, and there'd be 2 left over. 5 minus 3 is 2. Okay, so negative 1 2/3 right there. Okay. And let's zoom back in for the y-intercept. So the y-intercept happens when x is 0. Well, this one's a whole lot easier. It's just y equals 5. So, right, wow. Okay, the scale, again, kind of funky. But there we go, roughly like that, yeah? So the x-intercept was negative 1 1/3, comma 0. And the y-intercept was 0, comma 5. Use the intercepts. Well, you know what? This one isn't in standard form, but that doesn't mean I can't mess with it as if it was, well, really whatever I want. I'm going to multiply it by 4 on both sides. So I end up getting 4y equals 1 minus 10x. There's nothing against that. Perhaps, as you notice, the graph has these fun little decimals. Anyway, the x-intercept is when y is 0. So we have 0 equals 1 minus 10x. Subtract 1, divide by negative 10. We get x equals 1/10 or 0.1. So x is 0.1. That's right here. And then the y-intercept, well, I gotta erase that, and I gotta put it back since I didn't. There we go. So the y-intercept, y-int is when x is 0, like that. So we just have 4y equals 1, so y equals 1/4, or 0.25, right there. There's our graph, something like that. The x-intercept was 0.1, comma 0. The y-intercept was 0, comma 0.25. You don't have to have that 0, but I did, just for the sake of communication. That 0 also, you don't have to have it, but there it is. Number 10, identify the graph of this thing. Okay, let's do it. Let's start with just the x-intercept. I pointed at the x, but really the x-intercept, you cross out y. The x-intercept is x equals negative 6. Well, check. See ya. And the y-intercept happens when x is 0, so the y-intercept is negative 10. And see you later, it's this one, because there's negative 10 right there. Blue on blue is not real helpful, sorry. Another one where it's identify the graph, no big deal. In fact, I like doing the multiple choice thing where I'm like, hey, not this one, so I'm going to keep going with that. The x-intercept is when y is nothing, so we get 5x equals negative 30. That's when x equals negative 6. This feels like the same problem. Oh, here's the difference. and this is worth pointing out. I know it seems a little silly, but I'm pointing out this one has a plus sign. This one has a minus sign. So it'll be interesting to see the difference, right? So like down here, this one looked like this. Has a negative slope for having, you know, an x plus y equals 10 type of thing. That 10, I know it wasn't 10, but I just threw in a random number, right? Okay. So anyway, back to this, -6. So see you later. See you later. So then, hey, you know what? I'm going to guess it's that one, right? Because of our whole, we had a negative slope here, even though it was a plus sign, right? Not too crazy, right? Anyway, let's keep going. Let's erase this. And now find the y-intercept. The y-intercept is when x is 0. So y equals +10 now. Oh, look. I was right. Interesting, right? All right, this problem is modeling real life. Your goal is to bike and jog a total of 150. Well, I mean, they've given us the equation, but I got to just tell you, total 150, it's going to be equals 150. That's just a word problem helper right there. And basically, if we were to just look at this, basically he's going to be doing something and something to get his total of 150. And then they tell us what it is. It's X is the number of hours you bike. Y is the number of hours you jog. Interpret the terms and the coefficients. Well, the first term is 12.5x, and there it is. The second term is 6y, and it's that. And the last term is 150, and that is that. And by the way, you might not know what this and that means, but I mean, I circled them as I said them. The big red sentence represents that one. The big blue sentence represents that one. The big purple represents that one, okay? And then the coefficients are, so like this 12.5 is the coefficient. That must mean that every time he goes for a bike ride, it's 12.5 miles. So that's bike ride is 12.5 miles, and a jog is 6 miles. Okay. Now they say graph this thing. 12.5x plus 6y equals 150. All right. The x-intercept makes me cover up the y. So it would be 150 divided by 12.5. So let's see. That's 12. 125 times 5. 10, 5, 2, 0. Yeah, 1,500 is at 12. So the x-intercept, 12. Which means this dude is going to do, he could do 12 bike rides, and that would be 150 miles. And then the other version is if he does the y-intercept, where you get rid of the x, and that would just be 150 equals 6y. So 150, that's 25. So there's his other option. He could do 25 jogs. And now here's the line. The x-intercept shows that you could bike 12 hours and not jog any miles. The y-intercept shows that you could jog 25 hours and you don't need to bike any miles. If you bike for 9 hours this month, how many hours must you jog to reach your goal? So we're biking 9. That's 12.5 times 9. Plus 6y equals 150. Okay. So let's see. I'm going to be doing some cheating here. Got a calculator. 12.5 times 9 is 112.5 plus 6y equals 150. If I subtract 112.5 from both sides, I get 6y equals 37.5. If I divide that by 6, I get 6.25. If you bike 9, let's see if that checks out. Biking 9 is right here. Yeah, sure, that's about 6.75, wouldn't you say? Or I'm sorry, 6.25. You will bike how many miles in 9 hours? That was 112.5. And then you would be 3750 for jogging. Add that up, you should get 150, by the way, which was the whole point of this thing. To find the x-intercept of the graph of a linear equation, can you substitute 0 for x and solve? No. You sub y equals 0 to get the x-intercept. Are the equations of horizontal and vertical lines written in standard form? Yeah. I can't remember, we talked about this in class. It kind of felt like, I think maybe we talked about it when it came to slope-intercept form. Here's the thing. These guys are considered special, okay? They're special cases. So if you were to have, 3x equals 9, I mean, that is a vertical line written in standard form. And then if you had a horizontal line, you could have 3y equals 9. Those would be in standard form. This would, again, that's x equals 3. This is y equals 3. Different lines, right? This one's horizontal. This one's vertical. Remember, it's Vux and Hoy. All right. How do you see it? An artist wants to earn a revenue of $2,700 selling paintings for $30 each and sculptures for $45 each. So just like I was saying earlier, this is a pretty easy setup because standard form is just like, hey, you want to sell 30-something of those, 40-something of those to equal that much. It wouldn't be as easy in, slope-intercept form. So anyway, interpret the intercepts of the graph. Okay. So according to this one, well, actually, here, did they set it up like we set it up? Let's just double check real quick. So if we were to do the x-intercept, well, so that's 0, right? And you'd have 2,700 over 30. So the x-intercept is 90. Okay, so boom, it checks out the same for us. So the x-intercept is we sell 30 paintings, and the y-intercept would be you sell 60. So hold up, I should change that. Not 30, but 90. Sorry, I was writing down the dollar amount. 60 sculptures. And that should make sense because sculptures cost more, paintings cost less, right? So that is us interpreting the intercepts. Identify the domain in context of the problem. The domain would be 0 to 90 because we could sell between 0 and 90. And the range would be 0 to 60 because we could sell between 0 to 60. And that's it. There we go. Standard form online assignment. Let me know what questions you got.